My talk is about the Solr update chain. First, I'll introduce myself. Then I'll talk a bit about what is this update chain about. I called it the hidden update chain because it's not very much used until now. How many of you have used it for something? Okay, some of you. Good. We'll look at how to write your own update processors. I'll show you an example of a medium complex update chain from a recent project of ours doing web crawling. And try to mention some of the maybe limitations and give some pointers for possible future improvements. And then we'll wrap up. So, who am I? Jan Høydahl. I run my own consultancy company up in Norway with the beautiful nature and fjords. I hope some of you have been there or come to Norway. This is my wife, Hilda. And we love to do some kayaking and stuff. We're going to be parents in December, first child. So it remains to see how that affects the contribution to open source and everything. Some of you might have some experience of that.
Means you'll be awake in the middle of the night. You have nothing to do to write code.
Ah, cool. Can write code in the nights. Okay, professionally, I kind of started as a software developer within telecom in '95. And then in '98, my first shot at Java with IP telephony programming. And then in 2000, I entered the enterprise search space with FAST. I was engineer number 2 in FAST. So I've been traveling all around the world and seen a lot of enterprise search installations. In 2006, I did my first Lucene project, some EU project, also connected with FAST, actually. And then from 2007, I've been doing full-time consultancy, training, all these things in my own company with FAST and Solr Lucene technology. And this year, I became a Lucene committer. And all in all, through these 11 years, I've been involved in more than 100 projects when I count. So, yeah, I haven't managed to escape this niche yet. So, Cominvent, my company, it's the traditional open source thing, consulting, consulting, support, training. So if some of you missed the pre-conference training, there's a new chance in Oslo in 3 weeks. So, document processing. Why do we want to do document processing? If you're familiar with the Lucene and Solr, we have this analysis. And can't we just use the analysis? But as you might know, analysis is field-oriented, meaning your tokenizers, your filters can only see within this local field. So you can't really do, it constrains you a lot. There has been some attempt to extend this concept and to have a field modify other fields and stuff like that. But the way it is right now, if you have a title defined by the field type text, for instance, you can only do things within your title. You cannot start messing around with the document. So if you want to add or remove fields, or you want to do some decisions based on the content of field X and Y, and then write field Z, then we need to modify the document. One example, say you have a document with a person's CV. Well, you only have his name and his postal code and a link to the CV, say, in your database. So how can you then satisfy queries like a programmer or Java and a location? So maybe not the best example, but we could imagine we need a latitude and longitude based on the postcode to do this near thing, and we need the text of the CV, whether that is in PDF format or Word format or wherever. So currently, what people do, you could do this in your client side, of course, before you send things to Solr. You could reach out and fetch all these missing pieces, and there's nothing wrong with that. You could put a third-party pipeline in between, and you can do whatever inside of there. There's nothing wrong with that either. It could be the best solution for some cases. But today we're going to talk about Solr's built-in capabilities, which is called the UpdateRequestChain, actually. So I like to use this analogy that you have some documents that you send in, these packages, and then you can select a pipeline, a conveyor belt, where these documents are going to pass through a number of processors, which are these people in this case, to modify the document for different situations. And for our example, we have this document with the name and the postal code and the URL to the CV. So our first stage in this pipeline, or chain, would be a postcode to lat long processor. It's not rocket science. You can reach out to geonames, or you can find some lookup somewhere, and you write a lat long field. The next stage would be to fetch the CV from the URL. It's as simple as a URL fetcher. Then you get the binary representation of the rich document. And you can store that actually as a binary field within your Solr input document. But to get the textual version of the PDF, you need to do text extraction. And we can use the Tika, Apache Tika library for that. And we read the binary format, and we write a CV textual version. And then you have what you need to satisfy. Of course, you need to do some more to have a good answer to programmers near Barcelona, but then in principle, we can do stuff like that. Some of you might have seen this. It's my mental view of Solr's internal architecture. Where you, on the left-hand side, you get the content in, and it's processed and go down to the scene index. On the right-hand side, you get the queries in. So the update processing happens really right after the update request handler. It sends the document through an update chain, and then it's indexed. And those of you who have used this chain already know how to configure it in Solr config. There is an example, or actually two now, in the example Solr config of how to set up chains like this. So for our example, we will have a processor chain called CV chain. We'll have a URL fetcher processor with two config parameters, the input and the output field. And we'll have a postal code to lat long processor with some configuration and so on. So this is the way to set up your chain. Then how do you select which processing to use when you post your documents to Solr for indexing? It's actually more or less the same as you do when you pass parameters on the query side. You can do that on the update side as well. In this case, update.chain equals and the name of the chain. Then Solr will process those documents through that chain. And you can have as many as you want. Of course, you can configure this for all requests as a default in Solr config as well. But you can also override it per request. So some other examples of document processing. It can come in handy for language identification. We just got that into Solr 3.5 and trunk as a country module using the Tika's language identifier. Another example could be entity extraction. You could have a text and you can pull out company names, locations, and dates, for instance, and many more things. That fits also very well in this update chain. There is an example of that as well, another contrib, which is the UIMA contrib. It has capabilities to do stuff like that using standard UIMA plugins. There are also many other examples, of course. You can just imagine what you could do in a pipeline like this. OK, this is our cat. Her name is Rosasi. Anyone speaks Arabic here? No. Then I can tell you whatever, and you will believe me. Rosasi means gray in Arabic. So that's her name. So let's go to writing your own processor. And that's not difficult. It's very easy. You need actually two classes. You need your processor, which has a constructor. It can take whatever parameters, but typically you have the Solr update request and the response and the link to the next processor in the chain. And then you need to do some initialization to read the configuration and set up stuff. I typically do that in a method, init params. And then you have the main method for manipulating documents. It's the process add command. The processor also has other like process delete, process commit, other stuff, but most often you will need the process add. And in there you can get your Solr input document, and you can do whatever you want with it. The other part, of course, in Solr we always need a factory. We like factories in Solr. So to instantiate our processor, we need a factory. OK? So it's even smaller and simpler. It gets the request, the response, and the next processor in the chain, and you just create your processor however you want. Easy. And then you can refer to it. Put it somewhere on your class path and refer to it by class name. So some best practices, at least some things that I think is important. Make your processor generic. I mean, so that it not only solves your problem, but can do a good job for other cases as well. So parameterizing it in a good way is always good. Then we have these interfaces in Solr, different aware, like schema aware, Solr core aware, resource loader aware. Sometimes you need to get hold of other resources within Solr. Try to use these interfaces instead of just going to the Solr core for everything. It makes the code more readable. And then your parameters, your configuration parameters, are by default overridable on every request. So if it makes sense for your processor to override some of the parameters per update request, then make those parameter names kind of globally unique in some way. Typically in Solr, we prefix them with some short prefix so that we avoid name clashes when the number of processors grow. Of course, testability. Add unit tests for your processors and make them as testable as possible without invoking the whole Solr core and everything. So factor out things in methods that are testable by themselves. And of course, donate back your work on Jira to Apache and document it in a proper way. So we'll look at a real live chain from the University of Oslo, a project where we do web crawl. It may give you some hints of what you can do. So in this architecture, we have two sources. Well, everything is websites, actually, so it's web pages or PDFs and stuff. But some of the sites are served by a CMS system. So instead of crawling those, we push them directly. But the remaining sites, which are other kind of systems, we crawl by Apache Manifold CF. It has a web crawler, which is kind of easy to get started with. It has a GUI, and So that's good enough for small crawls like this. We have like 800,000 documents. And it's not a problem. So as you see, we select different update chains for these two sources. So we say update chain is CMS from the CMS and web from Manifold. And then we can do some different processing. That makes sense because from the CMS system, we have more quality metadata, which we can use for faceting. We don't always trust the dates and stuff from a web crawl. So we need some different processing. Document comes in from CMS, goes through the CMS chain, and from web, goes through the web chain. And here is a fragment of the configuration for the web chain. Can you read it? Yeah. I'll actually blow it up for you. The first is the language identifier. This, I already told you, this is in a contrib module from version 3.5. And the purpose of this is to take some fields, identify the language of them. We actually concatenate all the fields in the lang_id.fl, concatenate them together, and identify the language. And then we write the identified language out through to the lang field. We also have a whitelist. So we know that in our schema, we have set up field types with stemming for Norwegian and English. And if we find some other languages, we don't know how to handle them. So we just use a whitelist. If we don't find any of these languages, then we'll use the fallback. And we have fallback either from a field in the document or a hard-coded fallback. Then we have the lang_id.map. It actually maps the field name to some configurable regular expression pattern. The typical is to change the title. If it's Norwegian, you rename it to title_no. If it's English, you rename it to title_en, so that it matches your dynamic fields and the field types in your schema. And you have some thresholds and everything. There's a wiki page for this with a lot more parameters you can tune. So have a look at that. Then we have a regular expression replace processor. It's kind of generic. In this case, we use it to clean up the input, some data cleansing. Any white space or line feed, we just replace with the space. Because we had some problems with highlighting, actually. Highlighting counts white space as characters in the snippet size, so we got some problems with that. That can be handy. We have a fixed duplicate content title. This is an internal processor for the university. It will not be contributed to Apache, but it fixes some issues with the titles. URL classify, it's a generic one. It will output the host part of the URL, the path part. It will tell you how long the URL is, how many levels there are. If it's a top-level URL, it will give you a canonical version of it, so you can use for duplicate detection and stuff like that. So it's just a nice thing to put in the pipeline. Then we have a regular expression boost processor. It reads an external config file with regular expressions. So if it matches the incoming URL, it will apply a certain boost to the URL boost field, which is a float field in the schema. And then query time, we use a function, boost function, to apply that. So for instance, we use it to deboost certain, www/old. We know that this is low quality. It's public. It's supposed to be there, but we know that it's low quality content. So we can tune our relevancy. Then we have the static rank processor. It's giving us like anchor text and page rank simulation from external sources. So we have an external file with all this information, and we just match the URL. If the incoming URL matches, then we know the anchor text we should apply, and we know the page rank. We call it doc rank, not to get into trouble with some other companies. So this is also kind of generic. You can use it for typically web kind of projects. So the university has decided to donate stuff back to Apache, and that's always good. Thank you for that. So we have a field copy processor, we have the regular expression replays, and all of these I talked about, and you see the issue numbers. They will soon appear. So, more kayaking. If you come to Norway, you can enjoy this. This is actually going down a river. So we're going descending a waterfall through this. I don't know what they call it in English. It's these gates. The lock, that's true. So, is everything bliss with the internal update chain of Solr? Well, it's actually quite good. It's I'm kind of spoiled coming from the fast ESP world that has the world's best document processing pipeline, really scalable and can do all kind of things. But it's not really bad, the update chain either. You can do, for most projects, it can really, really give you value. But I'll highlight a few things that I can point out for you that maybe could be improved. One thing is that processors are recreated for every request. So if you have one request per document add, like the case is with manifold CF, for instance, it pushes one document at a time to the extracting handler. Then that can cause some problems. We have duplication of configuration between chains. If you have many chains, chances are that they will be more or less similar. No support really for nonlinear chains or subchains. It doesn't scale really well for like large scale. Maybe it shouldn't, but it doesn't. We lack a native scripting language support. By scripting language, I mean like JavaScript or Groovy or what have you. So, recreated for every request. What's the problem with that? It's potentially very expensive. In our static rank processor, we read and parse 50,000 lines of this anchor text and the page rank information. And that just kills performance if you're about to do that on read that configuration and parse it on every single update request. So what to do about that? We keep a persistent state because the factory is not recreated for every request. So we keep our state in the factory, and we push the state to the processor in the initialization, in the constructor. And then if it gets a state not null, then it can use it between requests. It solves this problem, at least for good enough. The duplication problem is not maybe a big problem, but our two chains share about 80% of the config. So you soon get into copy-paste errors and stuff like that. So a proposed solution would be to introduce named instances. So in the XML, you could imagine that we give a processor a name in addition to pointing to its class. And then we can just refer to those named instances in many different chains. So you see the Jira for this. We'll see if we end up doing it. What about the support for nonlinear chains? I actually got a question on one of the wiki pages about document processing about this thing. So the problem is sometimes you need to do some more advanced processing, like branching, subchains, conditional processing, stuff like that. And it's kind of not very intuitive or easy to do that. You can always code processors to do all these things, but we would like some better support. And I think the coolest suggestion for this so far is in Solr 2841, a scriptable update chain. So maybe if it will be Ruby or Groovy or JavaScript, depends on who wins that battle on the different camps. But in principle, you can refer in your Solr config to an external script, say updateproc.groovy. And there you define all your processors, you define your chains, and you can do inline coding like if type equals PDF, then you invoke the Tika processor. So you have all this flexibility available for you. It will also solve the redundant config thing, because you can just refer to objects and stuff in a much easier way. You could typically open a zip file and loop through all the content in it and put it in different fields, all kind of crazy things, which is hard in a linear setting. So we'll see where this leads. About the scaling, processing is really single-threaded. I mean, it's as single-threaded as indexing is. So the same thread that you send your update request to does the whole processing work and indexes it. So if you have a situation where you do much more processing, document manipulation, than you do indexing, then it doesn't really maybe add up. My cure for this is just to use more threads in your feeding. That's the way we scale indexing in parallel, and it will also automatically scale processing. So I think we went down from more than a day of indexing these 800,000 web documents to 3 or 4 hours just by going in parallel. In Solr Cloud and distributed settings, we could imagine that we have dedicated processor nodes, so that the receiving node just dispatches the batch to some processor node, which do all the hard work, and it could have many of those, and then it's sent further to indexing. So, but this has to be integrated somehow with Solr Cloud. But I think it's a way forward. If you have some external processing pipeline you want to use, but you don't want to recode all your sources and all your clients to send documents to that API, then you could send them to the familiar Solr API with XML or what have you, and then you can wrap your external pipeline in processor stage, and then just call out to it locally or however you want. So the lack of native scripting language support is not really a problem, but it would be nice to code your processors in your favorite scripting language instead of compiling Java. And you can already do that with Solr 1725. It's not committed, but it's working. So you can just wrap your script inside of this Java processor, and it will execute it for you. I hope that someday we can have this as a native feature, so that you can define your processor with script equals and a name of a script, and it will just make it look like a Java processor without wrapping it in this other processor. So I think that's the ultimate goal, so that you can write in whatever language you want. And one last thing. I'm wrapping up with, this talk has been about the internal update chain of Solr, which is good for many things, but I don't think it's solving all the world's problems. So there is interest for exploring a pure pipeline framework, which is much more advanced and can be integrated with Solr or with Lucene or with any other search engine. So search engine independent, scalable, a rich pool of processors, hopefully, because in my opinion, that's the core advantage of having some kind of common pipeline technology, is that you can share all these processors and you can reuse others' work. There are several existing candidates for this, and I won't go into that. But I mentioned them on the wiki page, document processing, and you're free to come and talk with me after this session if you're interested in joining this work or have some thoughts about how we could improve, or if there is one specific technology that you think would fit. Or if you know about any other open source processing frameworks out there, which I haven't found yet. So wrapping up, document-centric processing versus the field-centric processing of the analysis chain. The update chain is already there. It's kind of hidden, so not everybody knows about it, but now at least you know about it, so start using it. It works for most light cases, I would say if you start with this chain and at least explore if it can help you in your project, then you have everything within Solr, and it might be good enough for all your needs. It has its issues, scaling. You can use this caching technique to get around it, feed with multiple threads, and so on. And of course, more processors are very welcome. So if you maybe have one already, submit it. If you're thinking of one, write it and submit it. And that's it. I've already posted the slides. You find a link if you look up my Twitter name, Cominvent. And you're free to contact me. Any questions? So the question is, if you have this example where you reach out somewhere and you fetch a PDF, that would be one document at a time, and that's true. So how could you improve that and look at, fetch multiple documents at one time? And it's a good question. When you're at the document processor level, you're really looking at one document. So I don't have a direct solution to that, other than maybe having it somewhere locally, which is, at least not do that if you want to go wherever on the internet. But if you have it in a local web server or something, it would probably be good enough. So I realize that this example is maybe not the best. And the other one, to get the geonames lat long from the, it's not recommended to do that over the web service API for geonames, even if I have a processor that does that. And it's great for testing and prototyping. But maybe when you put things in production, you want to pull down the CSV files from geonames, index them locally, and do stuff more optimized. And I guess with your solution as well, you need to optimize things somehow. So the question is, aren't we replicating what Hadoop is supposed to do for us? Are we, shouldn't we instead maybe use this other technology? I think, again, we need to be pragmatic. Of course, we can use Hadoop for a lot of things, and it's nice, and it's cool, and everything. But at the end of the day, we can, data cleansing, data modification, transforming some stuff, cleaning up some titles, detecting the language. There is a whole bunch of things which you can easily do inside of this update chain. But of course, if you need to do some more heavy lifting, like processing huge logs and pulling out information, indexing it together, I guess you could combine these technologies, that you could have a Hadoop cluster with some web service that you can call out from the chain and ask for, hey, what is the reverse IP lookup for this? I got one question. If you kind of want to parse a document and you want to split it into subchapters and index those as separate documents, I would probably look into writing an update request handler for that, because then you can have the whole stream and the whole source documents, and then you could split them in the request handler, and you can ship them as those documents you want them to be. One tool is good for one job, another tool is good for another job. Okay, I think we're over time, so we'll call it today. You can talk more to me afterwards if you want to talk the generic pipeline thing. That's also welcome. Thank you.